Hey guys, I wanted to talk to you about dimensional analysis. I know you've done this in ninth grade. Some problems are, it's possible that you could solve them without dimensional analysis, just kind of using logic. But for what we're doing right now, we want you to be using this process because we're going to be building into more difficult problems. So dimensional analysis allows us to use the dimensions or the units of the things that we are measuring and then converting them to other units. So if you just look at this slide, it's just saying, we would want to know what we're starting with, what unit and quantity, and then what we're wanting to convert to. And then we can write an equality that relates the two units. It may be that we have one equality or more than one, and then we would multiply through and cancel the units, and then we'll end up with the unit that we want. So we're going to use conversion factors, and conversion factors they come from an equality between two different units that can be used. So examples of conversion factors, I know that there's 2.54 centimeters in an inch. So I can write that as a fraction as 2.54 centimeters over 1 inch, or I could do 1 inch over 2.54 centimeters, depending on if I'm trying to get rid of and cancel the centimeters, or if I'm trying to get rid of or cancel the inches. I have an example here. So this is a typical candy bar, and food calories are really kilocalories. So 150 kilocalorie candy bar, and how many joules of energy would that be? So we would need to know that kilo of anything, so a kilocalorie is going to have 1,000 calories in it. And then we can also know that 1 calorie is 4.18 joules. You wouldn't have to memorize that at this point. So if I'm doing the problem, I always want to start with the number they give me over 1. And then I'm going to multiply. So in the tutorial that you saw, they used fences, we call them, or railroad tracks like that. You can do that if you want still, but I think Ms. Snyder and I both kind of do it this way, and it's the same meaning, so either one is fine. So what we would do is focus on the kilocalorie here. So we would want to convert so that our kilocalorie unit would cancel, and we would end up in calories. So at this point, if I were to stop, I'm in calories. But in the question, they want to know joules. So I know I have one more step, and I'm going to want to get rid of the calories. So I'm going to put the 1 calorie equals 4.18 joules with the calorie on the bottom so that I can cancel those units. Then you can see the only unit that didn't cancel is joule. And then I can just do the math by taking 150 times 1,000 times 4.18. So let me do that with you. So 150 times 1,000 times 4.18. So our answer would be 627,000 joules. You can also write that in scientific notation, 6.27 10 to the 5th joules. And then later you'll learn about significant figures. There's 2 significant figures in the 150 kilocalorie, so we would actually round this to 6.3 10 to the 5th joules. So you'll learn more about that very soon. So let's continue. I'll just show you a few more examples. So this is an example. Shaquille O'Neal's foot is 41.2 centimeters, and we want to know how many feet that is. So we know that we're going to start with the 41.2 centimeters over 1. So to do this, I'm going to want to go from centimeters to feet, but I don't necessarily know how many centimeters are in a foot, but I do know how many centimeters are in an inch. And then I know that there's 12 inches in a foot. So I'm going to use both of these conversions. So first I'm going to get rid of my centimeters. So I'm going to use this top one. So 2.54 centimeters are in 1 inch. And again, you can see the centimeters are canceled. I'm in inches at this point, but in the question, they want to know how many feet. So I do need to continue. So I want to have feet. I'm going to get rid of my inches. And then I'm just going to calculate. It would be 41.2 divided by, but these need to be in parentheses. Otherwise, this number would come up to the top and you wouldn't get the correct answer. So when you do this, you should get 1.35 feet. So pretty big foot. All right, let's keep going. So we can derive conversion factors. The certain metric units you will be expected to memorize, and one of those is micro and the base unit. So one base unit, which could be a meter, a gram, is going to have 1,000,000 micrometers in it. Or you could write it in scientific notation, that 10 to the 6 micrometers. And by the way, I'm using this Greek letter mu for micro. And I wasn't able to figure out how to type it, so I'm handwriting it in. So it's kind of like an M that has a little bit of just a little bit different of a curve to it. So all of these, what I'm writing right now, mean the same thing. There's 1,000,000 micrometers in a meter, there's 10 to the 6 micrometers in a meter, or 1 micrometer is going to be 10 to the negative 6 meters. So you can choose to look at that however you want if you were to try to convert something from meters to micrometers. So the next example, we are going to use micro, and now we're going to use it in terms of grams. So for this problem, we're starting with a grain of sand, and the mass is 1.6 10 to the negative 7th kilogram. So I would write that over 1. And then I'm wanting to go to micrograms. You could possibly know how many micrograms are in a kilogram, but I know, the ones that I keep track of, that 1 kilogram has always 1,000 of the base unit. And then I know now that there's 1,000,000 or 10 to the 6 micro anythings, but in this case micrograms in a gram. So I'm going to choose to use both of those equalities. So when I solve this problem, I want to get rid of my kilogram first. So 1 kilogram is 1,000 grams. And then my next step, I'm going to put 1 gram on the bottom so that it cancels, and then my 1,000,000 or 10 to the 6 micrograms. So you could combine these and see that this would be 10 to the 9th if you want. So however your brain kind of processes this, but most people know, and you should know by the time you take the test, there's 1,000 of the base unit in a kilo, and then there's 1,000,000 of the micro in a base unit. So most people don't know that there's 1,000,000 micrograms in a kilogram. So when I solve this, I'm going to get 160 micrograms. One more type of problem. This one is going to have 2 units in it. So a tuna can travel up to 72 kilometers per hour, and we're going to convert that to miles per hour so we can kind of see, we're more familiar with miles per hour. How fast is this tuna going? So when I do this, I would need to know that 1 mile is the same as 1,609.34 meters. You wouldn't have to memorize that. That would be something I would give you. But I would also need to know, and this you should know, that there's 1,000 meters in a kilometer. So this problem, I'm going to start with my 72 kilometers, but I'm going to put the hour on the bottom. And you could put a 1 there if you want. Sometimes we would convert that time unit also, but in this case, we're just going to let it kind of travel with us for the problem. So I'm going to let the hour just stay there, but I'm going to try to get rid of the kilometer first. So I would put 1 kilometer is 1,000 meters. So you can see right now I'm in meters per hour. So then I would do one more step where I'm going to get rid of my meters and convert to miles. So those meters cancel. And then you can see the unit now is in miles per hour. So I would take 72 times 1,000 divided by 1609.34. And I'm going to do that with you. 72. So the tuna is going pretty fast. It's going about 45 miles per hour. So I hope that helps as you do these problems with dimensional analysis. Like I said, some of these might be easy for you in that you wouldn't necessarily have had to have done dimensional, but we're going to require that you do it because we're going to be building into other types of problems that you haven't seen.